Okay, question 6. This is a tricky projectiles question. Particularly part B I found was difficult. So with part A, I think it's always a good idea for these kind of questions just to do a quick sketch. So you've got a ball being projected, and then it's going to hit the ground at some point over there. So if we mark in all the things we know, so it's been projected with initial angle alpha. Let's just make that a bit better. So initial angle is alpha, and we know the maximum height is h. We also know the horizontal range is r, so r over there where it hits the ground again. And if we split the initial velocity up into components, horizontal and vertical, we will have horizontal component here, which will be v. Oh, sorry, I should have put a v in before. So the horizontal component for the initial velocity is v cos alpha. Vertical component here will be v sine alpha. Okay, so if we look at part A part 1, it's talking about h there, the maximum height. So because it's talking about the maximum height, we're going to need to resolve vertically when it's at its maximum height. So if we resolve vertically, there's supposed to be an arrow going up there. So we resolve vertically at maximum height. So that will happen when the velocity equals 0. It will be at its maximum height. Now, the things we know when that happens is we know that u, the initial component of the vertical velocity, is going to be v sine alpha. We know the acceleration, because we're resolving vertically going up, it's going to be minus g. S, the displacement, will be h, and v will be 0 because it's at its maximum height. Excuse me. So if we look at all those values, we can put them into v squared equals u squared plus 2as, and that will give us 0 equals v sine alpha squared plus 2 minus g times h. So that is v squared sine squared alpha minus 2gh, and rearranging we get this. And what does the question ask? We've got to get h on its own, so h equals v squared over 2g. Let's just check, is that what it says up here? Yeah, so where did the sine squared go? Sorry, don't know why I left off the squared there. So that's A part 1 done. And then if we try and do part 2 over here, we'll split this up here. So part 2, this time it's talking about r. So we're going to need to resolve horizontally for this. So if we resolve in this direction, when it's at r, so at r, resolving horizontally, we know that u is going to equal v cos alpha. We know the acceleration horizontally will be 0. We know the displacement at r is r, and we also, well, we don't know the time, so let's just leave it as t. So if we put all those values into s equals ut plus a half at squared, that will give us r equals v cos alpha times t and plus 0, so the acceleration is 0. So getting t on its own here, so that means that t will equal r over v cos alpha. Now if we can, if you look at the equation we need to end up with, there's no t there, so we've got to find another expression for t, another expression with t in it, and then we can substitute that in and eliminate the t. So what we can also do is resolve vertically at r. So if we resolve vertically as well, so when we're at r, u is the initial velocity in the vertical direction, is what it was before. S, the vertical displacement, oh, let's just do the acceleration first. The acceleration is minus g, and the vertical displacement is 0. Remember, this is still at r, which is this point over here. So you can see the vertical displacement is 0. Okay, and again t equals t. So let's use the same formula. S equals ut plus a half at squared. Putting the values in, we know s is 0, u is v sine alpha, t equals t, and then we're going to get minus a half g times t squared. We can divide everything by t. If we divide everything by t, we'll get 0 equals v sine alpha minus a half g t. Usually it's not a good idea to divide quadratics by the variable, because you lose the t equals 0 solution or the x equals 0 solution. But we know at r that t can't equal 0. That would represent this point up here. But if we're talking about r, then we don't need to worry about the time being 0. So we can divide it by t, and now we can substitute this in. So what we had up here, if we substitute that into there, we're going to get 0 equals v sine alpha minus a half g, and I've forgotten what it is already. Oh, r over v cos alpha, so r over v cos alpha. Now rearranging that, let's add all this to the other side, shall we? So we're going to get, well, v sine alpha is going to equal a half g r. Sorry, let's just tidy that up. So if we do g times r, and then put the 2 on the bottom with the v cos alpha, so that's just going to make it slightly easier to rearrange. So if we multiply by this now, there'll be 2v squared sine alpha cos alpha equals g r. if we put the 2 here instead, then it's more obvious that this is the double angle formula for sine. Okay, so I mean, even if you didn't spot that, go back to the question and you can see here we do need to end up with a sine 2 alpha, and as you know, sine 2 alpha is the same as 2 sine alpha cos alpha. So let's carry on. Whoops, didn't mean to do that or that. So v squared, all of this is sine 2 alpha, and so r is what we need to get on its own, so r equals v squared over g sine 2 alpha, which is what we're asked to do in part 2 there. Okay, part B, we've got to use what we've got here and this information about R0 being the maximum range to come up with this formula here. Okay, so it's 5 marks, so you know it's not going to be it's not going to be a quick question, and it isn't. So having a look at, if you look at this, there's no sines or coses in there, so we've got to eliminate any trig functions. Also, there's no v in there either, so we've got to eliminate v. Let's just deal with the R0 first of all, I think. So since R0 is the maximum value of R, this will happen, if you look at the equation for R, this will happen when sine 2 alpha is at its maximum, and the maximum sine can be as 1, isn't it? So that will happen when sine 2 alpha equals 1. In other words, RO will equal v squared over g. Okay, and since we're trying to eliminate v from our final formula here, let's just rearrange to get v squared on its own. So v squared is RO times g. Okay, so later on we'll need to use that, okay, to help us get rid of any v squares. Right, so going back to the question, we know that R equals v squared over g sine 2 alpha, which is the same as 2 sine alpha cos alpha. I'm doing this because then we'll be able to use the equation for h. So this equation for h, if we can get sine alpha on its own, we'll be able to substitute it into here. So, well, let's do that then. If we have, if I do it over here, so sine squared alpha is going to equal 2gh over b squared. This is coming from, this is just coming from here. Okay, just tidying up a bit here. All right, so sine squared is that. So obviously sine is the square root of that. So sine alpha, if we square root the numerator here, we're going to get 2gh. If we square root the denominator, we're just going to get v. Okay, so this can be substituted. Substitute this into here. Okay, so that will give us R equals v squared over g times by 2 2 times by this over v. All right, now we need to do something about that cos now. So cos alpha, well, if we remember that cos squared alpha is 1 minus sine squared alpha, then cos squared alpha is 1 minus this up here. Okay, so we can put that down there. So that is 1 minus 2 GH 2GH over V squared. Okay, and it's going to help us if we get a common denominator here, because then when we square root, the V squared will just become a V. So it's going to help us if we can just change this, change the 1 to V squared over V squared. Then we've got a common denominator, which just helps with the cancelling. So now we've got V squared minus 2GH all over V squared. So then now when we square root that, this is cos squared. So when we square root that, we're going to get the square root of the numerator, also the square, but the square root of the denominator is just V. All right, it still doesn't look that nice, but let's substitute it in instead of this cos up here. So that is all going to go up here to become square root of V squared minus 2GH all over V. Now it's looking like we can simplify the V's, well, some of the V's anyway. So that V squared will cancel with this, because these two will make a V squared on the bottom. And so just tidying up a bit, we've got R equals 2 over G times the square root of 2GH times by the square root of V squared minus 2GH. Now all those square roots could do with going, so let's square both sides. So if we square both sides, we're going to get R squared equals 4 over G squared times by 4G squared H. Sorry, not G squared, just the square root's going to disappear, isn't it? And the same here, the square root's going to disappear, but we need to keep that in a bracket. 2GH. Okay, so what do we know now? Well, this squared, we can get rid of one of these G's and cancel with that. Okay, now we're also good, so we're going to get 8 over G times H V squared minus 2GH. Now I think we need to remember that we don't actually want any V's. If we look at the question, there's no V's in there. So let's go back to what we had up here and get rid of the V squared. So if we replace the V squared, let's move that all the way down to here. So V squared can be replaced by R0G. So let's do that. Let's replace this V squared here with an R0G. So then we've got R squared equals 8 over GH ROG minus 2GH. This is looking good now because these G's are all going to cancel. And I think this is going to work out nicely because we've got 8H, multiply out the brackets, that'll be 8HR0 minus 16H squared. So if we get that to all equal 0, let's just put it, make sure it's in the form up here. Yes, okay, so we want to get everything on the left hand side. So that'll be 16H squared minus 8H RO. Or does it say RO first in the question? Yeah, so let's put the RO first. ROH plus r squared equals 0. Okay, one final check. Yes, that's correct. All right, that was hard work. All right, the next bit's a bit easier though. So let's go on to the final part, part C. Right, C part 1 is by far the easiest bit in this whole question. You just need to substitute the values in, substitute these values in, and then solve the quadratic really. So if we put those values into the equation in part B, we're going to get 16h squared minus 8 times 200h plus 192 squared, which is 16h squared minus 1600h plus 36,864. So just use your calculator to solve the quadratic and you should get h equals 36 meters or 64 meters. Okay, so that's C part 1 done. So even if you didn't know how to do part B, you should still be able to do part C just by subbing in the values to the equation it gave you in part B and solving. And then C part 2, so the last bit of this question, we have to find the values of alpha now. So the values of alpha that would give us these values for r and r0. So the equation for r, remember, given up here, r equals v squared over g sine 2 alpha. We need to know what alpha is, but we don't know what v is in this question. Okay, but if you remember part B, we used the fact that r0 equals v squared over g. Remember that r0 is the maximum range, so it happens when this equals 1. Okay, so we did that in the previous question. So that's helpful because now we can replace v squared with this, and we know what both r and r0 are in this question. So r equals r0g over g sine 2 alpha. So let's cancel those g's. And you can see this is looking good because we know that r in this question is 192. So we've got 192 equals r0, which is 200 sine 2 alpha. Right, we don't need to look at the question anymore. We just need to solve this and find the values of alpha. So sine 2 alpha is 192 over 200. So if we do inverse sine on our calculator, that's going to give us 73.7 degrees. I like to do the cast diagram for these, but as long as you've got a method that works, that's fine. So 73.7, and this here is positive, so we want to know where sine is positive. It's positive there and there, and so we want to reflect to get it in that quadrant. Okay, and then if we just find all the values, so we've already got this one. If we go around here, we've got another one here. So that would be 180 minus 73.7. So that would be 106.3 degrees. And then just divide everything by 2. So remember not to divide by 2 until the very end. Okay, and we should get our two answers now, which are 36.9, or dividing that by 2, we're going to get 53.1. So that's in degrees.